Okay, in example number 8, we're finding the inverse of a rational function. So the function c, which is equal to 20 plus 0.4n divided by 100 plus n, represents the concentration C of an acid solution after n milliliters of 40% solution has been added to 100 milliliters of a 20% solution. First, we want to find the inverse of the function. That is, find an expression for n in terms of C. Then use your result to determine how much of the 40% solution should be added to that so that the final mixture is a 35% solution. So we first want the inverse of the function in order to determine how many milliliters we need for a given concentration. So we will solve for n in terms of C. So in order to solve for C, okay, the first step, since we want to isolate n in this problem, is that we need to multiply both sides by the LCD. And the LCD is 100 plus n, 100 plus n. And so therefore, we can then eliminate the denominator on this side, and on the other side, we're going to distribute the C. Or we can leave it as C times 100 plus n, which is equal to 20 plus 0.4n. So now we can distribute the C to get 100C plus Cn, which is equal to 20 plus 0.4n. Okay, now our goal is to solve for n. So we want to get all the terms that have n on one side of the equation and everything else on the other side of the equation. Now it doesn't matter which side you isolate the n's on. In this example, they're isolating the n's on the right side of the equation. So we subtract Cn to both sides to get 0.4n minus Cn. On the left side, it's 100C minus 20. Now, 100C minus 20, we leave it alone. And on this side, we want to get n by itself. In order to get n by itself, you're going to have to factor out the n since n is in both terms. Now, in order to get n by itself, you're going to divide both sides by 0.4 minus C. So now solving for n, it's going to equal 100C minus 20 divided by 0.4 minus C. Okay, so now what we want to do is then we're going to answer the question. It says, use your result to determine how much of a 40% solution should be added so that the final mixture is a 35% solution. So we want to evaluate this function at 35%. So we're going to plug in the decimal version of 35%, which is 0.35, in for C to solve for n. So we have 100 times 0.35 minus 20 divided by 0.4 minus 0.35. We get 15 divided by 0.05 to get 300. So what does that tell us? We can say that 300 milliliters of the 40% solution should be added.